College Algebra Exam 1 Review 1.1 through 2.8. Each side of a square is lengthened by 6 inches. The area of this new larger square is 81 square inches. Find the length of a side of the original square. Now, the formula for the area of a square, given that they're talking about square inches here, right, and they are talking about a square, the area of a square is side squared. So, they say they take the original one, the original side, and they increased it by 6. Now, I do want to point out through inspection, you can actually find the answer to this really quickly, but I'll show you how to do it mathematically, right? So, for instance, we could say the new length of the side is the original side length plus 6, right? Where we'll put the S, right? We'll say that's the original. So we'll make that the original side length. And that's the one you don't know, right? Side length. And they're saying this new one, they increased it by 6, right? And that gave us the area of 81. So we know if we take that side plus 6 and we square it, then that should be equal to 81. Okay, cool. We square that and we get s squared plus 12s plus 36 equals 81. So we end up with this quadratic equation after expanding that. Now, if we want to solve this using the zero factor property, we would set it equal to 0 by subtracting 81. Cancel, cancel. We end up with s squared plus 12s, and then we would say 36 minus 81. So what would that be? Minus 40. Let's see, it looks like 45. Okay. And that is equal to 0. Okay, at this point we can factor it. If we're going to solve it using the zero factor property, we would factor this. So we would say square root of s squared is s. It ends at a negative, so it's going to be a positive and a negative. And we're looking at two numbers that we can multiply together to give you a negative 45. That if you add together would give you a positive 12. Now they're opposite signs, and since when you smush them together, when you add the negative and the positive together, you get a positive. You know the positive must have been stronger, and the negative must have been weaker. And if we add the negative 3 to the 15, we get a positive 12, which checks out in the middle, so we know we're dealing with a negative 3, and we're dealing with a positive 12. So solving a quadratic, first step, set equal to 0. Next step, factor. Next step, set the factors equal to 0. So it's going to be s is equal to negative 12. That doesn't make any sense, so that's not a valid answer because you're not going to have a negative 12 dimension for the side. The other one is s minus 3 equals 0, which means s is equal to 3, which in this case, this does make sense. This side would be equal to 3. This is what I was talking about with inspection. You could have easily just gone over a few numbers and figured out what number can you increase by 3 and then square, right? That will give you an 81. It wouldn't take you long to figure out 3, right? So 1 plus 6 is 7, 7 squared is 49, 2 plus 6 is 8, 8 squared is 64, 3 plus 6 is 9, 9 squared is 81, check, we got it. So you can do it by inspection. You can just kind of figure it out by playing with some numbers. And that might actually be the better way to do this one. But it does work. This is if you put it in the algebraic equation and you solve it, you do get the correct answer. And we can even verify this, right? We say the area of 3 plus 6 squared. And we say the area of 9 squared, and we say the area is equal to 81. Excellent. So 3 is in fact the correct answer. All right, the side of the squared is equal to 3. All right, solve by factoring. Solve by factoring. Okay, what can we factor out of a 5 and a 20? We can factor a 5 out. What can we factor out of an x to the 4th and an x to the squared? We can factor an x squared out. What does that leave behind? Essentially, when we factor, we actually divide these by what we're factoring out. You normally don't write this stuff. You just do it mentally. That's fine. But I'm just writing it out just to kind of illustrate what's happening. So the 5 cancel out. The x to the 4th divided by x to the 2nd. 4 minus 2 is 2, so I get x squared. Then you say negative 20 divided by positive 5 gives me a negative 4. And you say x squared divided by x squared. Those just cancel out, leaving you this. Now, we're not quite done factoring. We're almost done, but we're not quite. Because this is a perfect square, x squared minus a perfect square, 4. All right, so square root of 4 is 2, so you have a plus 2 and a negative 2. Difference of squares. So now at this point, we're going to use the zero factor property. We know that either 5x squared is equal to 0, x plus 2 is equal to 0, or x minus 2 is equal to 0. In which case, we know, I'll actually write the steps, but 0 divided by 5 is still 0. So you have x squared is equal to 0, and you take the square root of both sides, and you have x is equal to 0. Okay, then you have x is equal to negative 2, and you have x is equal to positive 2. So it looks like this had 0, negative 2, and 2 as your answer. That's a fine. In set notation, order does not matter, but when in doubt, just put it in ascending order. Put the smallest one on the left, the largest one on the right, and then you don't have to worry about it. But yeah, it's okay to not to have it in order in set notation. That's okay. Find the difference quotient of f of x is equal to negative 2x plus 4. Okay, now this is basically what it says. We're gonna, where it has the f of x there, we are going to be plugging in negative 2x plus 4. But here's the one we don't know, which is the f of x plus h. Well, we can figure that out. We simply go, well, what is f of x plus h? And what is f of x plus h? It just means wherever you see an x there, we're going to put x plus h, and then we're going to simplify it, right? So we distribute the negative 2. Negative 2 times x is negative 2x. We say negative 2 times h is negative 2h, and then we have the 4. And it does not look like anything else here. It's going to simplify. So what we're going to do is we're going to go plug it in. So where we see f of x plus h, that's where we plug in what we have right here, which is parenthesis negative 2x minus 2h plus 4. And then minus f of x. Well, what's f of x? Well, it's just the original one way over here, right? Which is negative 2x plus 4. And then we put it all over h. Okay, now we're going to simplify the numerator. I'm going to drop the parenthesis and distribute this negative 1 inside, right? If you're good with your signs, you don't have to do this step. Negative 1 times negative 2x is going to give me a positive 2x, and a negative 1 times a positive 4 is going to give me a negative 4, right? All right, now we combine like terms. We have a negative 2x and a positive 2x. Cancel, cancel. We have a positive 4 and a negative 4. Cancel, cancel. And that leaves us with a negative 2h over h. Cancels out the h's, leaving me negative 2. So it looks like the difference is a negative 2. We're going to write the interval notation for the intersection of the two graphs. You can graph it first. It didn't say write the interval notation for the. It didn't say graph it, but for illustrative purposes, you might want to graph it. So I'm going to graph it using different colors. Obviously, if you're on the test, you might not have the option of using different colors, but just for illustrative purposes, I'm going to do it. So let's say we do this one right here. So interval notation for the intersection. Now, intersection is where they overlap. So there's, even just visually, you can kind of go across here, right? So if you can imagine, like here, so there's a, let's say we have a line there. All right. So you can see at a certain point, these are actually going to overlap. And just looking at that, you should be able to easily tell. Now, because this one's filled in, the 5 on the bottom is filled in, and the top one, it's solid, we know we're going to include 5. And then because it goes off to positive infinity off to the right, we could just leave the positive infinity, in which case it's fine, right? So just looking at that, you should probably be able to tell. Another way of doing it is you could just redo the graph and try to graph both of them on the... So we're going to graph the top one, which should start at 4. And because the hole is not filled in, we're going to use a parenthesis. And then in the bottom one, we can graph that one as well. And we could say it starts at 5, which is right here. But because it's filled in, it's going to be solid. And we just fill that in. It goes off to forever. And because we are dealing with intersection, we care about where they overlap. And that means that we just bring down the symbols from above, right? That's a 5, goes off to positive infinity, and it ends with the parenthesis. And that's it, right? So you can either do it from the two that I give you over here on the left, or you could graph both of them up on the same number line and then come to the same exact conclusion. Let's try the next one. So we're going to evaluate the function f of x, the function in terms of x is equal to 4x squared minus 5 at the given values. All you're going to do is you're just using different notation, but you're still just plugging it in. So all you're going to do is rewrite the original function as it's written here, but wherever it has the x, instead of writing x, you're going to write -1. So order of operation, PEMDAS. Parentheses first, nothing you can do inside, next to exponent, so negative 1 times negative 1 is a positive 1, or negative 1 squared is equal to positive 1. Next, we're going to do the multiplication. 4 times 1 is 4. 4 minus 5 is negative 1. So we got the first one. Next one is a little uglier, but it's still the same concept. 2x plus 5. Wherever you see the x, you're plugging this in. Okay, we're going to simplify this a little bit. I'm going to use a pattern on the first one. So that's going to be 2x times 2x. It's going to be 4x squared. Then I'm going to say 2x times 5 is 10x. 10x doubled is 20x. Oops, 20x. And then I'm going to say 5 times 5 is equal to 25. And then we're going to keep the negative 5. Next, I'm going to distribute that. 4 times 4 is a 16. 16x squared. 4 times 20 is 80x. 4 times 25 is 100. And 100 minus 5 is 90.